Today I'm gonna try to make something similar to this shape. A rose looking like a green rose looking like this thing. So let's try to do that in Grasshopper. First of all, I'm gonna make a point on the center to start with. And I think by looking at the image, kind of a look could be constructed from a spiral based curve, so I could start by making a spiral curve. Let's make a line on x-axis and something with some lengths. Okay, and in order to make it as a spiral, I should be reparameterize first, and let's divide this curve to some large number of points to make high resolution, so something like 400. Okay. And then let's make a simple series with the lengths of points, and I'm gonna use this series for the step angle to rotate this each point. Oops. So the step angle could be something like 26.5. Gonna change this to radians and rotate the points with this angle, and it already look like a spiral, I guess, if I connect these together with the nerves curve. Yeah, it's a spiral. Okay, now I also want to make it going upward so that I could make a rose like mountain. So in order to do that, I am gonna move these each point to z direction, and for the z value I can use this value t here, and I can just connect it directly, but it's just going like linearly upwards, so I don't want that happen. So I could use a graph mapper to map the parameter here with the vector, I guess. And I'm gonna change this shape something like this. And I also have to set up the height, the maximum height of this value, how much I wanna make it upward. And let's hide all these. And yeah, some spiral curve has been made. Spiral points again. Okay. Now from this point, let's make a curve using interpolate. It's a lot of curves. If I decrease this, you can control the spiral curve like this one. Let's make it like this. Okay. Now this is the point making a spiral curve, and I want to pick some of the points in order to make a leaf, each leaf of this row. So I will use this patch to the point that's been moved upward, and I'm gonna make some trim false list. Only the true one will be outputted from A. So first of all, let's make a true as our first item on the list, and there's also a false. And I can only control, let's only control the number of false in the list so that I can have like in what step I should get the point. So I could use duplicate data for the false and set the number of false numbers in the list, and finally merge those two together. Let's flatten this to make it as a one list, and you see that first items will always be true and the list is false, and I can control the number of false. And if I put it to the P, I can get from what I get from P, what I get from A, output is the point that's on the 10th item, every 10th item. Oh, that's good. Let's increase a little bit of more points. Somewhere around here, okay. And let's hide those, and these are the points, and this is the curve. Oops. Okay, so now that I got a point, let's get the tangent vector of this point in on this curve, which I can do with the CP curve closest point. Set the points in here and set the curves, reparameterize this first and set the curve here, and evaluate the curve on this parameter. Now I get the tangent vector, this one. Now using this tangent vector, I could rotate 90 degrees with the z-axis. In this case, 90 degrees to the negative direction. Okay. And let's make a line. So I want to make a leaf here, so I want to make a line like this one first, as being a base of the leaf. So let's make a line STL from this point to the tangent vector direction, and the lengths could be derived from, I guess, the index number of this point. So I could make a list of this number of points on the curve, and let's make a range, and I will make an expression x minus 1 from the total count of the points and put it on the n, and the value will be between 0 to 1. So I will use the graph mapper again to remap this. Something like this, and remap again, using the remap component from 0, 1 to something that I want to use as a length of the leaf, the width of the leaf. So I'm gonna make a construct domain and set the domains something like 0.8.4 to, I don't know, 38.1, and use that value to construct the line. And do I see anything? Oops, I had to set this to target. Okay, here. Okay, now the line starting from the edge of the point, from the point, so I have to move half size of the length to the other side. So I can just move this to the direction, to the negative direction, so I will amplitude the direction, this one, with the minus value, minus 0.5 value of the original line length. Okay, here you go. Okay. Now that I got a point, right now it's too straight for a leaf, so I want to make it as a curve, or it could be an arc, so I will remake this line as an arc. So I will use the endpoint of this line as an endpoint of the arc. I just need to add one more point to the outside of this line. So first of all, let's get the endpoint of this line. And for the center point of the arc, what I could use is this one that I have made before. The vector value, and that's rotated from the tangent vector of this line. So I'll amplitude this vector by the length, how much I want to move, let's say. And the length I want to move could be also derived from this value, I think. So I could just reuse this line length, maybe multiply with some factors and use it as a line length of the outside point. Now could be like 2.25 or something between 0 to 1, and move the center point, which is this one. Now that I got 3 points, I could make a arc from 3 points. First one is this one, second and third. And yes, I think I got the arc curve. That will be the base of the rows. Okay. Now from this one, what I could do to make it like a rose, I could move this base curve with the scale from somewhere around the center to go outside and make a loft to actually make a leaf. I don't know if you call it as a leaf, but it's okay. Let's make a center point for the scale with the construct point Well, it could be starting from the center, but if I go start from the center, then the bottom leaf will go like horizontally extruded, so it doesn't. I don't want that, so I have to move this point a little bit to the downward, to the minus direction of the z-axis. So let's make some value, how much I want to move this. Negative, negative. To the z direction and use it as a center of the scale and scale this with the positive number of the scaling. Now for the scaling value, I could again use the range somewhere starting from here. Maybe I could derive from here or just directly from here. Let's try to derive from here. And since it's a scale function, what I would like to do is to scale between somewhere around 1 and somewhere around more than 1. Well, I could do from 1 to somewhere 2.40 something. Okay, and connect it to here. Let's check the tree data. Okay, looks good. Let's connect here. And looking fine, I guess. If I increase, I decrease the number right here. Okay, well, let's see if I use the range here. Okay, let's see if I connect this here directly to here. Maybe this is better. Let's see that later. Now I have two curves, one the original base curve and one that's scaled up outside curve. Now let's graph those two and merge it together so that I can make a loft between them. And cannot hard to see what's going on, so I'll make a preview. And as a base it looks okay, but it doesn't really look like rows at this point. It's too straight up, too mechanical. So I guess I need some random values in order to create looking a little bit more organic. So what I could do especially for the outside curve, I could make some randomness on the edges. So what I will do, I will divide the curve on the extruded edge, scaled edge here with the divide point, and let's set the parameter for the number of edges to be divided, and let's make a random and put P to C to S seed, so that each point will generate random points. Okay, the random value is from 0 to 1, it's fine. And simplify this. Okay, let's shift this. I should be simplifying this. Oops. Okay. And let's multiply this value by the value that I wanna randomize the edges. Could be somewhere around here. And let's also divide the base curve as well and make a vector 2 point from base to the scaled up. Okay, and I think I have to set the same data tree. I need to shift this first and make an amplitude with the value here and vector here, and move the outside point, which is this one, with the vector, and construct the NURBS curve out of the moved point, which is more random, become more random. Now I guess this extrusion to the outside thing could be derived again from here. So let's make another remap, and the maximum could go like 20. Let's make it a float. And the minimum could be like 5. Just to check. And connect it to here. And I have, okay, first of all I have to make a shift. And for this one I have to graft. And multiply this. Now let's check if I decrease this. Yeah, I think it's doing its job. This here is really aggressive, but should be okay. I mean, better than the last one, I think. Let's hide those together and reconnect this, simplify this, and reconnect it here. And let's see how I look like by hiding all these. And yeah, I look more like a rose, but I don't really see changes here, so I think I need to I'll try multiplying this point to make it more, see it is more obvious. Okay, that looks good. That looks too randomish. What if I control this? It's around the same. Now I can just decrease this number a little bit less, so to make it less noisy. Yeah, something around here. Looks good. Okay. Now let's thicken this leaf so that I could make it more like a rose. It's just a plain right now, so in order to do that, I could just take a surface. Oops, it's not a surface anymore. Let's check. Open B-rep. I see. It's a B-rep. How come? Ah, okay. I also have to remake the NURBS curve using for the base curve as well, to make it as a surface. Okay. Now I have a surface. Let's reparameterize this, make an area. To get the centroid and evaluate the surface using the CP closest point on the surface, and evaluate this surface to get the normal vector, which is this one. And using that normal vector, I could extrude the surface with some specific thickness. Now this thickness could also be derived from this value again. Let's try that. So the bottom will be higher, I guess. Let's just use this one to see how it's being made, how it's gonna be made. So put it here, and for the amplitude value, which should be a grafted value of this one, and see. Wow, it's look too thick. Let's preview this. The maximum minimum is too large. Let's make both 5 as a maximum. And if I change this one, okay, the first value is controlling the thickness here, so make it thin as possible for the center and make it thick for the outside. Maybe I could just try from here for this one. Yeah, it looks better. Okay. Looks okay. Maybe it's too much leaves on it right now. Let's make 10. And less points. Yeah. A bit better. Now there's so many parameters that I set that how you can control the shape. So it really depends what parameter you choose to make as realistic as possible or fantastic as possible. Okay. Now this is pretty much it for one rose, but as I wanted to make as a rose garden, maybe let's try to array this to some geometry on top of some geometry. In order to do that, to make it lighter, in order to array, I will make it as a mesh first. So brep mesh brep, and make it as low poly as possible. Call settings, speed, doesn't really change. Setting, custom settings for the mesh. Now the default looks fine. Well, it doesn't really look good on mesh, so what I would do, maybe I could just change the surface into mesh first, like this, and set some parameter for the min edge and max edge. Let's make it float. Let's make the maximum 20. Okay. And extrude this using the mesh thicken component, and use this value that I use for the extrude directly to here. Okay, and let's not use this one. All right, and let's see how I look like. Oops. Preview. Let's hide the mesh edges. Yeah, looks okay. Now I could also use a Weber's subdivision to make it smoother. Yeah. In that case, I could make it more low poly, like this. Yeah, and I realize I need more randomness. Okay, looks okay. Yeah, probably that's okay. And maybe I could go with a bit more thickness. Let's make the maximum 10. Maybe it's too roundish. Okay. All right. It's fine. Okay. Now, let's array this on top of some geometry. I'll just choose a sphere to make a planet-like rose garden. Let's set the size to somewhere like 400, maybe less, 300. And set this to high quality. And simply populate some points on top of this geometry with a specified number of points. And get the normal vector of this point on a surface, so I could do this evaluate surface on the sphere for each point. And now that I got a frame, I also want to rotate the rows randomly on this frame, so I'm gonna use the random and let's put the points here on the seed. Okay, so the range is from between 0 to 2 pi, so I could just put, yeah, I had to make a domain, construct domain. Pi to the r. Now that I got the random value from 0 to 2 pi, I could just connect here, but it's grafted, so make it flatten. Now that I got a frame here, where I want to put, okay, let's first flatten this rows, base rows. What's this? And make a group. And since it's been made on 0, 0, 0, I could just use XY. Oops, XY for a base plane and use the orient from XY to this here frame. Now that I got placed flowers on the sphere, to make it more look randomized, I could also make a scale with the random scale value. So let's make a range from construct domain somewhere the maximum could be 1, the minimum could be somewhere like 0.63. Put it to the scale here, and the center will be this one. Let's flatten this and scale this geometry. Now, as a result, you'll have a kind of a randomized scaled rows. Now finally I could, let's show the sphere as well. Let's color this to something, I don't know, white is good, I guess. And for the arrayed flower, arrayed rows, I can ungroup this. Let's color this using some graph, color gradation, gradient. Now I could just use the default, but to make it a bit more interesting, what I could do, I could first make a range with the length of the points, length of the leaves, I mean. Here, and this is from 0 to 1. Then I could multiply this value using this random vector, random value, which I use for the scaling, and connect this here. And as a result, I should be having a color value. Let's simplify this. Okay, so I could simply preview or mesh color. This each mesh with these curves, and in order to do that, I think I need to graph this first. And with this color, which I also need to graft, and okay, I'm missing some normal value here. It's just deleted the, how do I say, the normals in order to make a shade. Now I think it's because of I used the subdivisions. It somehow deletes the normal now, and I'm not sure if I can fix this with the components, so maybe I could use a little trick here to normalize using the C#, which I don't know if people would accept it as a tip. Okay, first of all, have to normalize normals, compute normals. Okay, it doesn't work. Okay, I guess in Rhino, when you set the color for the vertices, you don't really get the shadings. So, well, in that case, I could just use the preview color, custom previews, in order to color the rows, and looks fine. Looks fine. It does look like a rose, yes. Let's increase let's set the size of the sphere a little bit smaller so that it will be dense. Somewhere around here. Alright. Looks good, looks good. Now let's set the color of the rows a bit more like this one, greenish. Red is also okay, but I guess I want red one. And here, round here. Good. Looks good, I think. Let's increase the number of points. And that's about it. This is how you can kind of make a rose-like shape and aerate it as a garden. Yeah, there's much more things that you can make it more neat as a parameterize wise. But there's so many controls that you have right now. You can make all sorts of rose-like curves. Sometimes it doesn't really look like a rose like this. Like here. Or the length of the rose, whoa, becomes more flowerish. I mean, rose is a flower. More dense. Yeah, so there's so many parameters here. You can play with it to see what's doing what. Okay. That's enough for playing. Thank you.